Okay, so today we discuss the remaining hybridizations. So that is first we discuss Sp3d2 hybridization. So in the name itself it is there one s orbital, 3 p orbitals, 2 d orbitals intermixing. So you can write the intermixing of one s orbital, one s p orbitals, how many? 3. Okay, 3 p orbitals and 2 d orbitals. So forming same number. So same number means here how many participated? So 1s. Okay, 1 s orbital, 3 p orbitals, 2 d orbital, totally 3 plus 2 1 was 6. Okay, the 2 d orbitals forming how many numbers? 6. Okay, forming 6 new identical hybrid orbitals. Is called Sp3d2 hybridization. The formed hybrid orbitals are called Sp3d2 hybrid orbitals. Okay, the formed hybrid orbitals are called Sp3d2 hybrid orbitals. How many are formed? There is 6. The intermixing of 1s, 3p and 2d. In the name itself it is there, s is 1, p3, d2. So forming how many participated? 3, 5, 6 are participated and the new 6 are formed. So we can represent it like this: 1 s orbital, 3 p orbitals, 2 d orbitals forming sp3d2. sp3d2. How many? 6. 6 sp3d2 hybrid orbitals are formed. So then what will be the percentage? So what is the percentage of s character and p character and d character? So how many units are there? There is totally how many units are there? So there is 6 units are there. Means 6 units you will get how much? So each will get each unit will get the s character. S character is how much? 16 point, so 100, 1 2 3 4 7 6 means by doing dividing 6 we will get 16.66 percentage. And what is the p percentage? P percentage means the p character. So how many are there? So the how many it is 3 units are there. 1 2 3 units are there. So the finally they will get approximately 50%, that is 49.98%. we can write 50%. So next, what about the d? So how many d's are there? 2 units of d are there. So 1 unit is having how much? So 1 unit is 16.66. How many d units are there? 2 units are there. So obviously it is having 33.32 percentage. Okay. So approximate percentages. Next, what will be the shape? Okay. What is the shape of the 6 sp2 hybrid orbitals arrangement? Okay. So already we know the formed hybrid orbitals always takes a position involves in a shape where they will get more distance and less repulsions. Okay. So in any hybridization we observe that the formed all hybrid orbitals are arranged in such a shape in which they get more distance and less repulsions. For example, in the sp hybridization only two are formed. Only two are formed, but they are in opposite, they are linear. In sp2, the three are formed. That is triangular planar. In sp3, four are formed. So 4 on the more distant shape is tetrahedral shape. So in sp3d, the 5 are formed. So 5 on the perfect shape, trigonal bipyramidal. 6 on the perfect shape. 6 on the more distance, less repulsion shape is there is only one possibility. That is the shape in which they arranged is octahedral. Octahedral. Next, what is the angle? What is the angle between that hybrid orbitals, adjacent hybrid orbitals? What is the angle? Okay. So the angle is in octahedral. So there is two possibilities are there. So next we draw the structure on the shape. So octahedral means we will get the perfect bond angle 90. So one and unofficial bond angle we can get, that is 180 degrees. So this is Sp3d2 hybridization. Okay. So now we see what is the shape of octahedral. So why it is called octahedral? Even it is having a number 6. Even it is having a 6 hybrid orbitals. So general octa indicates number 8. But here how many orbitals are? How many hybrid orbitals are formed? So there is a 6 Sp3d2 hybrid orbitals are formed. There is also possibility of formation of 6 bonds. So 6 bond formation choice on the kada. But why it is treated as octahedral? Okay. So what is the octahedral shape? We see now. So the shape is octahedral shape is like this. So it is a square planar. Okay, square planar. Okay. This is the 4. These 4 are exactly. See here, these 4 are exactly present in a single plane. Okay, these 4 sp3d hybrid orbitals. Okay, the one is this direction, this direction, this direction, this direction. Okay, so 6 kabatti it is not an easy to draw the hybrid orbitals, but we are drawing that the direction of that hybrid orbitals. Okay, so it is first direction, second, third, fourth. These 4 are present in one plane. Okay, one plane. So it is just like imagine a ceiling fan having 4 wings. So generally we use the fans, ceiling fans with 3 wings, but in rare cases we observe some fans are having 4 wings. Okay, so generally fans look 4 wings decorate. So 4 wings around all are in one plane. Okay, so all in they present in one plane. So above the rod, so paina on the rod ki opposite ga below the rod. Okay, so atla total 6. So 4 wings laga the 4 untai. So one is above that plane. So next one is exactly below that plane. So like this there is a 6 are present. This is 1, 2, 3, 4, 5, 6. This is treated as octahedral shape. So even it is having the 6 bonds. Okay, see, this is 1, 2, 3, 4, 5, 6 bonds. Why it is, don't put this type of lines. Okay, just for counting I did it. So 6. So why it is called octahedral means there is 8 angles are, so again, so what is the angle between two adjacent hybrid orbitals? So what we write the bond angles? Just now we said the bond angles are, main bond angle is 90. Just think that in a square planar. Okay. First I am discussing about the bonds. The orbitals present in a plane means so 1, 2, 3, 4 ఈ places లో bond angle చూద్దాం. Bond angle means ఇక్కడ angle between the hybrid orbitals. So ఇక్కడ మామూలుగా triangle తీసుకుంటే how much? 120, 120, 120. Total become 360. But here 4 similar parts are there. So this is total is okay 360. Now just guess 140 is how much bond angle? So 90. This part 90. This part 90. 90. So 90, 90, 90. Okay. So అదే మనకి so triangle లో exactly planar triangle లో 120, 120, 120. So in the same way, this is the square planar. Square planar. So adjacents are having 90 degrees. Okay. So that is the 90 degrees is okay. Like there is also other place, at other place also 90 degrees is present. So can you guess where the 90 degrees is present? See, this is the rod. Okay, this rod, this is a wing. అంటే ఇప్పుడు ఫ్యాన్ కున్న ఈ రాడ్ ఇమాజిన్ చేయండి, ఈ ఫ్యాన్ కున్న ఒక వింగ్ ఇమాజిన్ చేయండి. అంటే ఇక్కడ సో ఇట్లా ఫ్యాన్ కి ఓకే నార్మల్ మనం ఫ్యాన్ పైన రాడ్ తీసుకున్నప్పుడు 4 వింగ్స్ ఉన్న వింగ్స్ మొత్తం ఎట్లా ఉంటాయి? సో దిస్ ఈజ్ ఫస్ట్ వింగ్, సెకండ్ వింగ్, థర్డ్ వింగ్, ఫోర్త్ వింగ్ అనుకుందాం. సో ఈ రాడ్ కి ఈ వింగ్ కి వాట్ ఈస్ ద బాండ్ యాంగిల్? సో ఇట్ ఈస్ ఎగ్జాక్ట్లీ 90 degrees. అండ్ దిస్ రాడ్ ఈస్ హ్యావింగ్ 90 degrees విత్ ఆల్ వింగ్స్. ఆ వింగ్స్ కి అన్నిటికీ 90% యాంగిల్ ఉంటుంది. సో అంటే దిస్ యాంగిల్ ఈజ్ ఆల్సో 90 degrees. This angle is also 90 degrees. So this is the main angle. So next there is also possibility of the bond angle 180. So where 180 degrees is present, so the four are in one plane. So these are like this. Okay, one plane lo untai. So above this plane, below this plane, two bonds are present. Now the bond angle between these two bonds, okay, these two bonds are treated as 180 degrees. Okay, but officially we treat the only bond angle is 90 degrees. So this is also one of the possibilities. Okay, now we explain this hybridization with an example. So draw the diagrams neatly in a bigger size, not very small in size. So why it is known as octahedral? So after example I will explain it. See the example. Sulfur hexafluoride SF6. Okay, sulfur hexafluoride SF6. Okay, so what is the central atom? So obviously it is the sulfur, only one atom is present. So we know that central atom only involved in hybridization. So the central atom is what? Sulfur. So what is the sulfur configuration? Sulfur means how much? 16 atomic number. So what is it? 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz. So how many will come? 16 means 10, 12, 13, 14, 15, 16. it is like this. So there is also vacant orbital is there. Vacant 3D subshell is there. So in SF6 sulfur should make bonds with 6 fluorines. Okay, sulfur should form bonds with 6 sulfur atoms. So kabatti there must be 6 unpaired electrons should be there. So if possible it involves, if not possible try to get any other possibilities, but there is a vacant DA is there. So D lo how many boxes will be there? The 3D is called subshell. In 3D again the 5 boxes are there. Each box is treated as a orbital. Now at first the 3p electron shifted to 3D. Okay, so that is treated as excited state. The first electron, only one electron transferred, that is called first excited state. The first excited state, so it becomes so px1, py1, pz1, 3d1. So now how many unpaired electrons are there? Only there is 4. Okay, so to get 6 bonds, there is any other possibility? In valence shell 3s2 is there. If it also shifts here, so actually we written only 3D. Actually the 3D is having 5 boxes totally. Okay, so 3D is having 5 boxes. It is already D1. Okay, so next so 5 possibilities. Naturally if with one shift out, again it is shifted to here. So the second electron also shifted. Okay, second electron also transferred to the other vacant shell, vacant orbital, that is treated as second excited state. Okay, that treated as second excited state. You must understand about these excited states. Okay, 1s2, 2s2, p6. Okay, now it becomes 3s1, px1, 3py1, pz1. So 3D, so 1, 1, 2 separate are there. Okay, it is shifted here. Okay, it is shifted to here. Okay, so I am not writing the dxy in other model because no specific orbit boxes will be given. But think that there is 2 boxes are present. So now this one s orbital, 3 p orbitals, 2 d orbitals combined together, forming 6 Sp3d2 hybrid orbitals. This name is based on the orbitals involved. So 1s, 3p's, 2d are involved. That's why we are giving Sp3d2. How many will form? The number of orbitals are participated. The 6 are participated, 6 will form. Now these 6 are ready for bond formation. Yes, these 6 are ready for bond formation because they are all having unpaired electrons. Okay, next, so that is about the central atom sulfur. Okay, next, what about the fluorine? The side atoms. The fluorine works 9 atomic number. So 1s2, 2s2, 2px, 2py, 2pz. So 9 means is 2, 2, 1. So means in fluorine, which orbital is ready for bond formation? This pz1 is ready for bond formation, as it contains 1 unpaired electron. Nothing but unpaired electron and 1 unpaired electron. So like this, how many are there? There is 6 fluorines are there. At a 6 fluorines flow, pz1, 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 6 pz1 are there. The 6 PZ ones overlaps with the 6 different Sp3d2 hybrid orbitals of sulfur. Just understand carefully. So these are looks very easy, but when you try to write the questions, it becomes somewhat critical. But that's why you need to understand perfectly. Means now these 6 are overlaps with the 6 fluorines. Okay, so 6 fluorines to involve అయిపోతాయి. See now, so how many are formed now? There is overlapping of the overlapping of 6 Sp3d2 hybrid orbitals of sulfur. So write completely, okay. The overlapping of 6 Sp3d2 hybrid orbitals of sulfur having unpaired electron. The overlapping of 6 Sp3d2 hybrid orbitals of sulfur having unpaired electrons with the p orbitals of fluorine having unpaired electron. Forms a 6 sigma Sp3d2 p bonds. Okay, the overlapping connection rastamante 6 Sp3d2 p bonds. Okay, so all are having single bonds, but they are sigma. 6 sigma Sp3d2 p bonds are formed. So then what is the final shape? So what is the final shape? We know that the Sp3d2, if a molecule having the central atom which undergoes Sp3d2 hybridization with 6 bonds, with 6 sigma bonds, that must undergoes octahedral shape. That compulsory undergoes octahedral shape. Then what is the bond angles? Okay, so adjacent bonds angles. What is the bond angle? So we know that any octahedral. So octahedral means the bond angle is 90 degrees, and also there is possibility of 180 degrees. Okay, it perfectly works in a SF6. Now we see the shape of a SF6, and now we see why it is called octahedral. Even it is having 6 bonds. First I draw the SF6 shape. Okay, so this is square planar, central atom sulfur. It is having bonds. So already we know what type of bonds. Sigma Sp3d2 p overlapping. It is coming from bottom side, kabatti we used the dotted line. So this is the perfect shape of a SF6. Okay, this is called octahedral. This is SF6. 4 fluorines are present in one plane, above this plane and below this plane 2 fluorines are present. They are all sigma bonds with 90-degree bond angles. So now this is completed. Step 6 is over. Now see why octahedral shape. Why it is treated as a octahedral. So octa number involves generally 8. Okay. So octa number involves 8. So but there is a 6 bonds are formed. Then why it is treated as octahedral means the overall structure. So that is it appears like 8 angles. Just understand carefully. So because I am trying to explain you. So this is the center one. So it is having 4. So here also one is present. Here also one is present. So just think that these 4 corners are connecting to this upper line. So this upper point. Okay, now it become like a pyramid. Okay, just like a pyramid. So pyramids, we know that pyramid having a 4 angles, 4 surfaces. So 1 2 3, one is back side, so 4 surfaces. So in the same way, attach them to the bottom point. So these are the bottom points. Okay, so now we can observe there are 8 angles, 8 surfaces are present. Okay, so how it is just like a diamond. Okay, it appears like a diamond because so upper part it was like this 1 2 3 4 surfaces. So in the same way, it's the bottom. For example, then water on the body. Then imagine water low exactly shape in the same way. It is exactly like that. So ikkada 4 mali daniki bottom lo 4. So middle lo plane. Middle lo 4 bonds on the plane. So that pine oka pyramid laga, then bottom lo oka pyramid laga. So kinda unna oka corner connect avute, pine unna oka corner ki connect avute. So means we are getting 8 surfaces, 1 2 3 4 upper side, the down side kuda 4 surfaces, total 8 surfaces. That's why it is treated as a octahedral. Okay. So next we see the other lost hybridization, that is Sp3d3 hybridization. So there is a very rare molecules are present in this hybridization. Okay, that's why I am not giving total definition. So we can understand that easily now. So it indicates that so the intermixing of 1 s orbital, 3 p orbitals and 3 d orbitals. So forming how many will form? So there is a 3 3 6 1 7. Okay, what will be the name? Sp3d3 means 7 Sp3d3 will form. So now what is the S character? What is the S percentage? What is the P percentage? What is the D percentage? So there is 7 units are present. So each one treated as a 1 unit. 7 units are present. The total percentage for 100. So there is each one is getting 14.28 percentage approximately. So this is 14.28. So S is having 14.28%. So then what about P? Okay, P is having how much? So how many units? So 1 unit is 14.28. Then what about 3 units? approximately 42.84. Okay, so the D also having 3 units. Okay, so approximately that's 42.84, not exactly, so I will get 84 something. 42.84% approximate values. Okay, so next, what are the bond angles? So here the shape and bond angles are important there in this Sp3d3 hybridization. The formed 7, here 7 are formed. How they adjust their shape, how they get a shape to get a less repulsions and more distance is, so it is not easy to get a perfect shape for 7 hybrid orbitals to get less distance, sorry, to get less repulsion and more distance. So therefore they involve a shape treated as distorted. Distorted means just changed. Okay, changed. Distorted means some changes are present. Distorted octahedral is called distorted octahedral. Next, what will be the bond angles? Here the bond angles are, means now we are discussing the single one. So angle. So what is the angle between the hybrid orbitals? So between the hybrid orbitals bond angle is, so 7 and the distorted octahedral low, it is 72 degrees and 90 degrees. Okay, so these are the bond angles present in it. So then what is the shape? Okay, so what distorted octahedral shape is here. So here see, normal octahedral is like this. Okay, 1 2 3 4, 1 2 3 4. So above the plane, below the plane. So octahedral means some change, distorted, ఒక place లో కొంచెం change అవుతుంది, so that it becomes somewhat like this. There is a formation of fifth bond also takes place. So this is called a distorted octahedral. Distorted octahedral. So octahedral one part కొద్దిగా change అవుతుంది. That's why it is called distorted octahedral. So we can write it like this. The 5 bonds, 1 2 3 4 5. So 5 are in one plane. Okay, so మనకి trigonal bipyramid లో 3 are in one plane. అదే మనకి octahedral లో 4 are in one plane, just like square planar. Here 5 are in one plane, and above the plane one bond is present, and below the plane one is present. Okay, this is totally 6 7 I think. 1 2 3 4 5 6th position and 7th. The number is our choice. We need to count the total number, that's it. So this is also treated as, so actually what these 5 are, so how these 5 are present? These 5 are present in one plane. Okay, so one plane, so one plane lo unnayi kabatti this is treated as a pentagonal bipyramid. So 3 ఉన్నప్పుడు triangle ఉండి above the plane below the plane ఉంటే that what is a triangular bipyramid. So ఇక్కడ 5 ఉన్నాయి కాబట్టి we can treat it as pentagonal bipyramid. So the shape can be written as a pentagonal bipyramid shape. Okay, now we see one example for it. So there is only one example, either that is a rare example. So directly we are writing that that is iodine heptafluoride. So IF7, iodine heptafluoride. Okay, so It's like this, the same shape. This is iodine, like the 5 fluorines, 1, 2, 5, and here so other fluorine. Okay, so this is IF7 iodine heptafluoride. So there we just make some angle. Okay, so this is iodine heptafluoride, which in which iodine undergoes Sp3d3 hybridization. Okay, so now it forms how many bonds? 7 sigma bonds. Okay, so this is about the different type of hybridizations. Okay, so next tomorrow we see some more molecules involving in all different type of hybridizations. Okay, so but just read all type of hybridization once. Okay, because tomorrow we discuss all hybridizations randomly for different molecules. Okay.